So this question says the amount of ants in a colony F that is decaying can be modeled by f of x is equal to 800 times 0.87 raised to the x, where x is the number of days since the decay started. By what percentage is the colony decaying? And then we want to write an expression that shows the amount of ant population that is lost after a week. And also we want to calculate the remaining population of ants after, 3 days. All right, so here we go. Always, always, always just highlight important information so we know this is the equation that models the decay that is happening. They clearly state that it's decay, okay? And we know it is going to be decay based on what we know to be true about the equation for an exponential function. So we know y is equal to a times b to the x. I keep writing this over and over because I know that the more we see it, the more we're going to be able to remember it. So this is initial value or growth factor, which is representing decay in this case because it's less than 1. All right, so or decay factor is 0.87. So as we continue, what do we know? Well, the growth factor for the remaining population is 0.87. That was given in the equation. So the population lost is going to be 100 minus 87, which is equal to 13%. And if you're like, wait, what? So remember 0.87, we can change that to a percent by multiplying by 100. So if we multiply 0.87 times 100, we're going to end up with 87. So that's how we get the 87. And when we subtract from the original or the initial value percent, that's going to give 13%. So we know that 13% of the ant population was lost, and we also know that the function is modeling a decay pattern. Now, as we continue, so we're saying that, hey, our growth factor is 0.87, and that means 87% of the ant population remains. And this also means that 13% of the ant population is lost. So if we want an expression that shows us the ant population that is lost after 1 day, they should actually say 1 day. So let me fix that. After 1 day, then going back to or y is equal to a times b to the x, or initial value was 800. And the percent that represents the loss is going to be 13%, which can be represented as 0.13. So we're multiplying 800 by 0.13, and this is after a day. Now the ant population that remains after 3 days, we're going to have to use the percentage that represents the remaining population of ant. So that is 0.87. That is occurring over a course of 3 days. So our initial value 800, and we're multiplying by 0.87 3 times because it's 3 days, which can be simplified or written in the exponential form, 800 times 0.87 raised to the 3rd power. When we simplify that, you can put this in a calculator. We're getting 526.80. No, we know an ant is an ant is an ant, so we don't have 0.8 of an ant, so we're going to round that to the closest whole number. So we're going to estimate that there are 527 ants in the population at this time.